All right, in this example for number 3, we're supposed to use reference points. I'm just copying the directions down so you know. Use reference points. We're also going to have to complete the table. Complete table. Graph it. And then determine if it is a even, odd, or neither function. Great strategy for me. I don't know about you. When you get a big paragraph of instructions, if you can list them out as steps and then put check marks as you complete them. All right, in this problem, we need to use reference points. Well, reference points are, we already have the function here in the graph. And we have to kind of figure out, well, they already gave me the parent function, so we did this previously in your packet. This right here is the parent function, right? We already know it's called c of x. Now it's telling me g of x is now 1/4 of c of x. So here's the question. What does 1/4 tell us? Class, is that on the inside or outside?
Outside.
It is on the outside. What letters can we choose from now? A and D is correct. Does the A and D value affect the X or the Y? So we have an A value. I know it's an A value because it's on the outside, and then A values affect the Y coordinates. In this case, we have multiplication. So what we're going to do is, let's write that. A equals 1/4. And basically what we're going to do is we're going to multiply by 1/4. Just on the Y coordinates. So let's multiply by 1/4. Now remember, the X coordinates stay the same. So class, what's 0 times 1/4? 0. 1 times 1/4? You have 1/4, right? You have 1/4 or 1/4, so that would be 0.25. 8 times 1/4. Remember, we talked about how multiplying by a fraction is just extending that fraction line over 1 and then multiplying across, so you get 8/4, which is what? 2. So you just get 2. Okay, so we just completed the table. Let's use reference points. These are the reference points that we use. Let's go ahead now and graph this. Let's use blue. So now I'm going to graph blue. 0, 0. 1, right 1, and then 0.25. It's like barely over, right? Right 2, up 2. And then I'm going to do the same thing going in the other direction. Left 1, down 0.25, and then left 2, down 2. So my graph's going to kind of look like this. Okay, let's review what we've done so far. We used our reference points for the yellow. We completed the table by observing that the only thing that's different about c of x is that there's something in front. That's our a value. The a value affects the y coordinates, so we multiplied and got our new coordinates and graphed it. And now we need to determine if it's even, odd, or neither. Well, I know if it's an even, we have a silly phrase. What is it, class? Evenly. That means it's symmetrical about the y-axis. Class, can I fold my blue graph across my pen?
No.
Does it fold and it's exactly the same? No, it's not. Okay. Odd functions. Odd functions graphically means that O, odd, O, origin. Class, is it symmetrical about the origin?
Yes.
Two ways you can think about it, corner to corner, or you can also rotate it 180 degrees. So in this case, the answer is odd. It's an odd function because graphically it is symmetrical. Now you could also test that algebraically by putting in -x for every x value and then look at the outcome.